Okay, welcome back. It is day 184 of coding every day. So today I haven't done anything. I'm going to do it right now. Tomorrow is the start of the research program. So again, I don't know what tomorrow's going to look like. Ideally, this was kind of like just a chill weekend. Um, so ideally throughout the next just summer. I like mornings. I want to dedicate to this program. Afternoons maybe dedicate to like my personal work, and then the evenings a mix between this research and the startup that I'm a part of. So most of those evenings will be going to this probably. Again, I actually don't know. It could be I'm a 9 to 5 in the lab here. I won't know until after probably tomorrow. I don't know how intensive the work is going to be. Um, so yeah, a lot of stuff that needs to be answered tomorrow. But yeah, just gonna do a simple leetcode today. Very simple because I want to go to bed because it's a pretty early start tomorrow. Um, so yeah, let's do this. Okay, leetcode. I'm gonna do like an easy, like high submission that isn't JavaScript or SQL. Mm-mm. I heard that my like research is going to be using 3D modeling. So my actual research is in um my actual research is in smart home systems for people with autism. And so we're not working with human subjects. So I assume it is going to be simulated stuff that we are putting in and then writing stuff for that. I have no idea. That's what tomorrow's for. Um, this is definitely JavaScript. Number of good pairs. Aha. Given an array of integers nums, return the number of good pairs. A pair I and j is called good if they're equal, if the values are equal to each other, and the index is less than this index. So we have a pointer probably at both the start, right? But we want one that's before it, so we'll do one and one plus that. And if this and this are equal to each other, then they're a valid pair. Okay. I mean, you could do. I mean, when you're counting pairs, I used to always do the loop of like you look at this and then you go through the whole loop and you go to the next one, but that's kind of inefficient. Uh, that's O of n, not squared. Is it squared? You're going through the list that many times. Okay, so it is O of n squared. So we don't want that. So it would probably be, well, we're going to return a count, right? How many good pairs we have, and we want a frequency dictionary. And for each number in nums, what? It should be if num is in our frequency. If we already have a record of this, because, okay, so the whole idea I'm thinking of is anything that we've seen earlier is valid to anything we see later, right? So instead of using two pointers, we can just look at it as like, look at the first thing, for nums and nums. If it's in there, right, then we increase the count. Otherwise, we just add it to the frequency table, right? So, I mean, the else here is going to be frequency at num is equal to 1, right? That's the amount that we have in there. And so then we say, okay, if this number is already in there, then we want to increase it, right? frequency at num plus equals 1, right? And then I want to say count. Actually, do I need to? Is it not just increment count? Because if we ever just find a good pair, so like here it'd be like this is an L, so it gets appended. That gets appended. That gets appended. And then here count becomes 1, 2, and then here it becomes 3. I want it to be multiple. So oh, because it's actually we want the actual amount of frequency, right? Because if it's in num and then we look at the frequency that's already there, right? Because it'll pair with all of those. So I mean, is this frequency at num plus equals 1 and count plus equals frequency at num? Output was 7. Output was 7. In what world is this an output 7? Okay. So for each num we go through, is this in there? No, because we have nothing in there. So now frequency at num is equal to 1. We have one of these. This happens for both of these. Then we get here and we're like, okay, we have a pair, right? And I'm saying frequency at num plus equals 1, right? So now frequency is 2, and then we say the count plus equals the frequency at that number. But we don't have two pairs, we only have one pair. So are these reversed? What would that look like? I mean, what's the logic? Because then I would look and I would say count would be 1, and then we have 2. So then 2 would come by, and then we go to the next one, and then we'd, I guess that would be we add 2, because, but like, I don't know if this is a hack around it, because that just seems weird. Because like, yeah, it's 2 because we have a pair of this and a pair of this. I guess it is the frequency, right? It's how many others we can match it with. Yeah, this has to be it. Yeah. Yeah, that makes sense. I was thinking of like, I was thinking of it as like the number of pairs, but that's not it. It's just the number of instances. It's a frequency table, right? So for every single time you find a pair, just how many pairs, how many elements are already there, you just add those because it's going to be that many pairs. So, okay, that is all that I have for today. I will let you know how tomorrow goes tomorrow. Yeah. Okay. Good night. Take care. Bye.